antennas. So smart antennas means the most efficient antennas to reduce the losses. And in this video we are going to see about why we need smart antennas, what is smart antennas, and how smart antennas are working. So why smart antennas first? So to increase the capacity, largely increase the capacity, and to increase the range we are using smart antennas. It is having the potential to introduce new services, and it is having more security and reduced multipath propagation. And if we want to see, so it as it is giving more efficiency, you have to check what is smart antenna first. So in a cellular system, the radio communication is between user and a base station, we know that, and it provides radio coverage within a certain area called a cell, we know this. So each and every antenna which is communicating or through to the satellite is from base station to the user to the base station, like that we are having connections. And all these base stations are having omnidirectional radiation pattern, or we may call it as sector, that is 65-degree over all the three directions around the direction. So this is wastage of power, as most of it will be radiated in other directions than towards the user. The power radiated in other directions will be experienced as interference by the other users, because whatever we need is only giving the efficiency. Whatever which is out of focus are considered as interference to other users. So in smart antennas we are having the facility to utilize the full power over one direction itself. So that's why we go for smart antennas. So the idea of smart antennas is to use base station patterns that are not fixed, because in the previous type we are having fixed radiation pattern which is diverging out its power in all the directions, which may, some of it can be used, some of it are wasted. But here in smart antennas we are not having fixed radiation pattern, but it adapt to the current radio conditions, so efficiency is to the full. So this can be visualized as the antenna directing a beam towards the communication partner only. And this is the illustration of smart antennas, where here this green line is the standard 65-degree sector antenna, and the red one is the phased array antenna, where user 1 is using it, and it moves in clockwise direction. Blue line is phased array antenna, user 2 with a counterclockwise movement, and gray one is other sectors. So see here, this gray lines are not needed, because both the users are using only one pattern, and that pattern is only activated using smart antenna to utilize the most of the power over that direction itself. So this is the illustration of smart antennas. And here whenever we are studying about the smart antenna, we have to know the sharing of radio spectrum. So users communicating via same base station have been separated in various ways: by frequency with the FDMA concept, by time as with the TDMA concept, by code with the CDMA concept, or by space through SDMA concept. SDMA. So FDMA is frequency division multiplexes, TDMA time division multiplexes, CDMA code division multiplexes, and SDMA space division multiple access. The space division multiple access is only used in smart antennas. This is what we are studying. So the concept is smart antennas consisting of number of radiating elements, a combining or dividing network, and a control unit. Control unit can be called the smart antenna's intelligence. It is realized using digital signal processor using many filtering methods. So based on this definition of smart antenna, one can define levels of intelligence with smart antennas. So as the smart antenna is having number of elements with the control unit making the wave pattern or one particular direction, we may call it as levels of intelligence. The levels of intelligence are of three types over here: switched lobe, dynamically phased array, and adaptive array. The switched lobe is the simplest technique, also called a switched beam. It comprises of only a basic switching function between separate directive antennas or predefined beams of an array. The setting that gives the best performance is chosen over switched lobe. And dynamic phased array is based on direction of arrival algorithm included for the signal received from the user. Continuous tracking can be achieved. Generalization of the switched lobe concept is utilized. So dynamically phased array is the technique used before this adaptive array. So adaptive array, a direction of arrival algorithm for determining the direction towards interference sources is added, and the radiation cap pattern can then be adjusted to null out the interference. So adaptive array is the recent concept, and it is the most utilizable concept compared to the previous two. So see here, so the levels of intelligence are switched lobe, dynamically phased array, adaptive array. In switched lobe we are having lobe in all the directions, and over that the main lobe will only be considered in one particular direction. In dynamically phased array we will be having only one directional beam. It can be switched based on the direction of arrival. And in adaptive array we are having multiple lobes with a high gain, and it will be switched over the different direction based on the direction of arrival to show the adaptiveness within the network. So these are the three levels of intelligence. Based on this only smart antennas are designed, and nowadays everyone is using this adaptive array technique. And the evolution of smart antenna is based on three stages. Over the first stage, uplink with a high sensitive receiver, and over the second phase, downlink in addition to high sensitivity receiver, directed antenna beams are used. In the last stage, we have to use space division multiple access for the evaluation of smart antennas. So the drawbacks are mainly the cost factor, because the network function such as resources mobility management are needed, which may cost very high, and transceiver complexity is also there, because a smart antenna transceiver is much more complex than traditional base station transceiver. You have to change the full system, so it is very much complex. It need for more powerful algorithms, processors and control systems are needed for this. And resource management, new demands on network functions such as resource and mobility management are needed, as I have told now. And physical size, for the smart antennas to obtain a reasonable gain, an array antenna with several elements is necessary. And the smart antennas are tested with testbed development in Ericsson management trial in Gießen, Germany, and Tsunami 2 trial in Bristol, UK. And this is one of the picture of 8 element array at 1.8 GHz, which has been developed by antenna property of Telia Research AB, Sweden. So this is all about the introduction and the background study of smart antennas. I will see in detail about this adaptive array in the next slides, next presentation. Thank you.